we have here a cable is supporting a weight which is 50 newtons, and we're going to determine the reactions of the cables AB and BC. Okay, so what we're going to do here, actually there are two free body diagrams. First is the free body diagram at point B. So let's consider joint B. So when cables are structures being given in the problem, then we would always be considering a concurrent force system. So, for example, this is our point B here, and our point B connects cable here, which is, let's call this as cable AB, and another cable which is cable BC. Since they are both cables, then somehow it's going to be pointing away from here because that's a cable. Also, the point B is supporting the vertical load, and this is the load towards the force 50. So, or let's say that this is force or the weight. That's the force system. So I'll just draw a line for the reference of the angles, and then this is angle, let's just copy the angle of inclination, angle 45 here and angle 30. Okay, and then somehow, since forces or AB and BC are inclined, then might as well get the components. So for the horizontal of AB, it's pointing away to the left, so this is AB cosine of 30. And then for the vertical, this one, this is AB sine of 30. In the same manner, we're also getting the components of BC. For the horizontal, it's to the right, this is BC cosine of 45, and vertical upward, this is BC sine of 45. But what is the value of our W? For the W, we need another free body diagram. So for the free body diagram, by the way, this joint B is a free body diagram. So another free body diagram that involves only the circle or the weight. So the weight has, according to problem, it has a weight which is equal to 50 newtons, and this weight or this sphere or ibutanato, the object, is supported by a cable, and that cable is somehow adjacent to point B here. So what would be the direction? Of course, to supply equilibrium, we have to get the summation of forces vertical equal to 0. So to make it 0, since 50 is downward, which is always downward because that's a weight, so somehow this force here, or the weight W, is upward. So that you would adhere to the concept of equilibrium. So now we can have the summation of forces vertical, and we are getting W upward minus 50 as downward equal to 0. So therefore W is 50. So transpose 50 negative to the other side. So that's 50. But this is not our final answer. So as you observe, we have two different direction of W. The reason, because if we try to place back the W here, so if we try to move it around, so let's just say we're gonna place it back here, this this portion here, so let's just, oops, this one. So this portion here satisfies the equilibrium that whenever you place them back together, as you can see, it will not give you, or it will not create any vertical external force. So this is equilibrium. Since we have two different free body diagrams, then the two common force must always be in their opposite direction. So this one, we are gonna transfer this or copy, let's just copy this one towards here, for this is the free body. Okay, so now we have the value of W. So let's just erase this one. So since we have the W already and we resolve the components of the forces AB and BC, we will be using the summation of forces horizontal equal to 0. So for that, summation of forces horizontal to the right positive, to the left negative. Okay, so here we have AB cosine of 30 to be negative because it's to the left, then plus BC cosine of 45, and that's to the right positive. And there are no other forces along the horizontal except the 2. So this is equation number 1. Next equation is we can get from summation of forces vertical equal to 0. So upward positive, downward negative. So what are the forces vertical? You have AB sine of 30, and then plus BC sine of 45, and then minus W, and that's equal to 0. So for AB, sine of 30 at the lang siyang i-rewrite, then plus BC sine of 45, transposing W to the other side will become positive W, but what is W? Equal to 50. So this is equation number 2. So using the same equations, we will be using these to create or to have the two equations with two unknowns, concept of elimination and substitution. Then let's just use our calculator, because at the end we will be getting AB and BC values. From this calculator, you have negative AB, negative cosine 30, and cosine 45, and 0 for the constant. And then for the second equation, you have sine 30, and then sine 45, and you have positive 50. So this is AB 36.602, no, 03 newtons, and the other one is 44.289 newtons. So the first answer nga mo gawa sa mong calculator is the first term that you input in your